Okay, so good afternoon, ladies and gentlemen, dear participants. Apologies for starting the event a tiny bit late, but we had some technical issues we fortunately solved. So today we're gathered here to discuss a very important topic, so the intersection of Europe climate ambition and fair safety measure in the context of sustainable materials. As we strive towards Europe's ambition goal of cutting greenhouse emissions by 55% by 2030, it becomes increasingly evident that the materials that we use must align with our climate objectives while ensuring fair safety measures. The transition to sustainable materials is a key sector, especially such as energy, transportation, and housing, necessitates important consideration of fire safety as a crucial parameter in assessing sustainability and, of course, circularity. The transition to electric vehicles, renewable energy production, and other sustainable technology presents a new fire risk to our built environment. Therefore, proper measures should be taken in consideration to avoid any tragic consequences. Throughout our discussion here today with an excellent set of speakers, we will explore how flame retardants and other safety solutions can ensure that Europe meets its fire-safe standards within the framework of the Chemical Strategy for Sustainability. This being said, I would like to thank our colleagues from pinfa, the Phosphor Inorganic and Nitrogen Flame Retardants Association, for the kind support in the event organization, and of course, MEP Jarubas for taking the lead with hosting today's event. So just some quick housekeeping rules for those of you who are in the room. We have a Q&A session toward the end of the event. So please, when we reach that part of the event, feel free to raise your hand and we can take some questions. For those of you who are attending online, there is a chat box in the platform. Please feel free to use it only and exclusively to ask questions for speakers. And please remember to mention the name of the speaker to whom your question is best addressed. Without further ado, I would like to provide the floor to Mr. Jarubas.
Thank you, ladies and gentlemen, colleagues. Thank you to everyone who came here today to the Parliament, and those who follow us online for participating in this event focusing on fire safety and Europe's climate ambition, and the role of sustainable flame retardants in Europe's energy transition. Thank you, pinfa, phosphorus, inorganic and nitrogen flame retardants associations, co-organizer of our meeting, for the honor of hosting this event of the European Parliament Intergroup of Climate Change, Biodiversity and Sustainable Development. I welcome all you who decided to meet with us today. Welcome all today's speakers. I welcome all of you. We all understand that there is no turning back from the direction of Europe's green transition. This is not only because of pressing climate change, but also because of the international race to change the technological paradigm of the global economy. New competitive advantages are being developed and a new division of position in the production chains of this 21st century clean technologies are being set. However, the green transformation, whether in construction or transport, must be implemented wisely, considering the socio-economic opportunities of EU countries, but also the safety of new technologies, including fire safety. Today, apart from disasters, the biggest source of fire in the EU, especially in residential houses, is caused by faulty electrical installations. The green trend means more installations, more electricity, both in constructions and transport. The green transformation also means greater use of organic materials, such as wood. This creates new fire risk. Without proper preparation of services protecting our lives, health and property, and without appropriate preventive measures, including proper design and adequate materials, we cannot talk about a safe green transformation. We must therefore complement the green transformation with solutions that will also guarantee fire safety for EU citizens. Many of you perhaps recall the last event I have hosted dedicated to fire safety in the context of Green Deal in cooperation with the European Fire Safety Alliance. We met in November as part of the European Fire Safety Week 2023. The result of the meetings of the European Fire Safety Week were incorporated into the Fire Safety Manifesto 2024-2029 with recommendations to ensure fire safety for EU citizens. We have Mr. Krzysztof Biskup, the chair of the European Fire Safety Alliance, with us today. So I hope we will be able to touch on this more during today's discussion. Indeed, as the manifesto calls, the coming Commission and the next Parliament should work to establish EU fire safety strategy fit for the new realities of the Green Deal. I wholeheartedly support the manifesto and its specific recommendations like raising awareness and competences of services and institutions, but also of the general public regarding new threats or scientific research aimed at more effective fire prevention already at the design stage, but also more effective response to existing fire threats. With this, without further ado, I'm changing all into ears. The floor is yours. Thank you.
Thank you very much, Mr. Jarubas, for setting the scene to today's event and also for your dedication on the topic of the event. So the next speaker today, and it's the key presentation of today's discussion, is going to be Adrian Bird, who's the chairman of pinfa Europe. So Adrian, I know you have a PowerPoint, so I will display it for you. But can you give us a clearer definition of what flame retardants are and what are the key role when it comes in the context of the current green transition?
Thank you very much, Regine, for this kind introduction. It's a great pleasure to be here and to talk about flame retardants, non-halogenated phosphorus, inorganic and nitrogen flame retardants. You've heard the long name a few times already. And I've tried to summarize in a very few slides the topic, and those of you not so familiar with flame retardant and flame retardant technology, to give a bit of context what we're talking about. So if we go to the next slide, Regine. Just a quick word on pinfa. Who is pinfa? And here on this slide, you see many, many logos of our member companies, not only in Europe, but we also have sister organizations in China and North America. In Europe, we were founded in 2009. And you see amongst these logos, big, well-known chemical or polymer compounding, producing companies, but also smaller companies and even end users of flame retardants, like my colleague Laurent from Schneider, who's an associate member of pinfa. So pinfa not only brings together the producers of flame retardants, but also end users to promote and discuss this technology of flame retarding materials, which are mostly polymers, but can also be textiles or wood or other applications. And our aim is to reach out not only along the value chain, but also to regulators, also environmental groups or authorities to discuss the properties of our products, not only technically, but also in terms of health and environment. Going to the next slide. Yes, why are flame retardants important in the context of fire safety? Not only in these emerging new strategic technologies, but also existing applications in building and construction, electric installations. But these new technologies that you see here, data centers, photovoltaic installations, batteries, electromobility, they all have in common the increased use or high consumption of electricity generation, distribution, and electricity, because of its energy content, bears a risk for ignition. If there are electric short circuits or faults, that can lead to ignition and fire, and that needs to be protected against. Going to the next slide. What can you expect of flame retardants? And we're not claiming that flame retardants are the solution to fire safety overall and in general. What flame retardants can do and what they're primarily intended for is to protect against an ignition from a small flame source, like this Bunsen burner that you see here with a small flame. That's a standardized test. that is frequently used in the electric industry, and where the test specimen that you see at the top of the two pictures does show some combustion behavior, but when you remove the flame, it doesn't continue burning, but stops. And that's what flame retardants typically are intended to do, so prevent against an ignition from a small flame source or ignition source. It could be a small flame like here, but there are also other tests that mimic electric faults, like a glowing wire. It's actually called a glow wire test. So an overheated electric wire is pressed against the sample, and then you check whether the material ignites or not. So that is, I think, important to keep in mind. Flame retardants protect against the initial ignition of a material, and they can also protect against further fire propagation. And we see that in the next slide, I think. Yes, what can flame retardants typically provide is more time for escape of people if the fire does happen to occur. So best case in a fire scenario is there is an ignition happening, or an ignition source takes place, but the fire doesn't even start because of the action of the flame retardant. Second best case is, yes, there is an ignition, and these pictures here show a timeline, temperature versus time. So at the x-axis at the bottom is over time, and on the left-hand side, without flame retardants, the fire may develop very quickly. And this is the scenario in a closed room, like a house or a residential setting, but it could also be a room like this, where there is an ignition. And if there are fire-protected materials, and that's the case on the right, it takes much longer for the fire to develop fully, so it gives people more time to escape. That's also one important aspect to keep in mind. But of course, other fire safety technologies like compartmentation, sprinklers, have all their role. And I often say it's like in your car. You don't rely on ABS alone. You also want a safety belt. You want good brakes. So it's the combination of these technologies that overall provides the good level of fire safety that we enjoy in the Western world or generally, and that we want to maintain. But these new technologies that are emerging also create new challenges. And I think my colleague Laurent will mention them later or come back to them in his intervention. Going to the next slide. And going towards the topic of the chemical strategy for sustainability, that now brings into play the whole environmental side and health side of the use of chemicals, and in our case, flame retardants in particular. With this publication of the chemical strategy for sustainability, we as PINFA have been thinking, what should we proactively do to respond to these new work streams in chemical regulation and promoting safer, more sustainable chemicals. And we have come up with 3 broad groups of activities here shown by the different colors. So one is providing more information and being more transparent on our products, and looking at topics like persistence versus durability. For instance, just to maybe mention that, persistence in terms of environmental behavior of chemicals means, does a chemical break down in the environment, which is generally appreciated or wanted, intended. But if you have a durable product, like a computer, a car, a house, you don't want those functional materials in there to degrade and break down quickly. So that's a kind of a conflict that is just inherent in the materials and difficult to resolve. We also have been thinking about commitments to sustainability, the blue section here. So when it comes to chemical regulation, REACH dossiers, improve the quality and information in REACH dossiers. We've been discussing substances of very high concern and their use and reduction within our portfolio. And on the right-hand side, projects. We have been thinking about how can we provide more information and more proof that our flame retardants are safe to use in terms of health and environment. And we have become engaged in these work streams or projects on safe and sustainable by design, which Iranzo will touch on later, to also test this methodology for flame retardants. How does it work, and how do flame retardants perform in this assessment, and how can they be practically assessed? And last point there, recycling is of course a more and more important topic. It is clear that the more mixed blended materials you have, and if you have flame retardants in polymers and plastics, they don't facilitate recycling, they make it more difficult. That is generally true, and we need to find solutions to that, and we are also actively engaged in research projects addressing this topic. And then coming to my final slide, which tries to highlight that there are many criteria, not only for flame retardants, but for, I think, chemicals in general, that they have to fulfill. So not only being performant, which you see on the, say, 4 o'clock section here. So they have to deliver the desired performance. They have to be economic. And that has so far been the main driver for choice of chemicals or other products, performance and cost. But now we have increasingly these other parameters: environmental footprint, safety, that means health properties, but also social value that they provide. In our case, the safety against fire, which can also create issues or have more pronounced issues with the less well-to-do part of the population. So all that has to come together, and I think for one, combining all those criteria and developing newer, better products needs effort. Will need also does bring cost with it, so it doesn't come for free, and it is a big challenge to combine all these. But as said, we have been working on these topics and we want to pursue them further. And this event today also shows our engagement, and that we want to reach out to other stakeholders to learn and also hear other views of this story or of this whole topic of fire safety and what role flame retardants can play in it. With that, thank you very much for your attention, and over to you, Regine. Thank you.
Thank you very much, Adrian, for such a comprehensive presentation, for showing us what flame retardants can do with some specific examples, and also for making the link of the work of the European institutions. So you mentioned REACH and the chemical strategy for sustainability, and of course for mentioning the holistic nature of today's discussion, so touching upon safety, social value, performance, economic value, and environmental footprint, as your last slide. So thank you very much for that. I think you gave us a lot of food for thought for the upcoming panel discussion. So I would like to present now the speakers who are taking place in the panel discussion. So joining us online, we have Iranzu Garmendia Aguirre, Project Officer at the Joint Research Center, GRC. Here in the room, we have Chris Slutweg, Professor at the University of Amsterdam. We have Laurent Tribu, technical expert of Schneider Electric, and also joining online, we have Christophe Biscup, Chair of the European Fire Safety Alliance. So the first question that I would like to address is to Iranzu, who is connected online. So considering the work of the JRC on the application of the safety and sustainable by design, what insights can you share today with us regarding the challenges and the opportunities encountered in assessing the sustainability of flame retardants? And of course, what is needed both from a regulatory and a scientific sides to move to more recycling of flame retardants materials? So Iranzu, you have the floor.
Okay, I hope that you can hear me.
Perfectly, yes.
Yes, okay. So thank you very much for inviting the JRC to this panel discussion. That's the first thing. Then, as Adrian, I would like to put into a little bit context the JRC work and the SSBD in order to be able to answer to the question. So yeah, you mentioned the JRC, and first maybe for all those people that don't know very well who we are and what we do. The JRC, it's the acronym for the Joint Research Center, which is Directorate General of the European Commission. and it's the Science and Knowledge Service of the European Commission, and we provide independent, evidence-based knowledge and science supporting the EU policies to positively impact the society. So we are independent of private, commercial, or national interests, and we work for more than 40 European Commission's policy departments. Maybe a little bit more. Our headquarters are in Brussels, but we have scientific sites in 5 different member states, and in total the JRC employs more than 2,000 staff. And among these works that we do for the different European Commission policy departments, we in the JRC developed as an action under the European Green Deal the safe and sustainable by design framework that is the topic of the question. As you know, among the strategies to achieve the Green Deal ambitions presented in 2019, we have the chemical strategy for sustainability that aims at better protecting the human health and the environment. And among the actions to achieve these goals, the CSS identifies the need to develop a framework to define safe and sustainable by design chemicals and materials in order to drive innovation towards the design and development of new chemicals and materials that are inherently safe and sustainable, but also to phase out the most harmful substances and to substitute as much as possible substances of concern or otherwise minimize their impact and track them. So as I mentioned, with the support of experts, we in the JRC developed, in order to give answer to this need, the safe and sustainable by design framework that in short provides an holistic approach to support the design, the development, the production and use of chemicals and materials that provide desirable function or service while being safe and sustainable throughout the entire life cycle, and providing the means to assess and evaluate the fulfillment of the mentioned Green Deal ambitions. So it puts together for the first time safety and sustainability dimensions with a life cycle perspective and to be considered in an integrative manner during the innovation. And for that reason, the framework serves as the scientific and technical basis of the Commission recommendation that was published in December 2020 for the establishment of an SSBD framework in research and activities, in research and innovation activities in a voluntary basis. And the recommendation envisaged through 2 years testing period to test and provide feedback on the implementation of the framework, and after which this framework will be reviewed in order to enhance its relevance, reliability, and operability. And in between the publication of the framework and the recommendation, the JRC, with the support of industry, already tested for the first time the framework in several case studies in order to evaluate the feasibility and applicability of the framework, to identify challenges and limitations in the application to be considered in future developments, to identify needs or gaps with regards to accessibility to data, information, methodologies, tools, expertise, and skills, and to identify the overlaps between as well the safety and sustainability dimensions. But it should be underlined that the objective of this testing was not to perform the assessment and draw conclusions on the tested chemicals and materials. And we tested the framework in 3 different case studies. The one fully developed by the JRC on non-phthalate plasticizers in food contact materials, and 2 other cases developed by companies with the support of the JRC, one on surfactants in textile scoring processes, and another one on non-halogenated flame retardants in information and communication technologies that, as Adrian mentioned, in which pinfa contributed. The results were presented in a workshop organized in February last year, and a technical report was published afterwards with covering these results. The report also covered addressing the question, challenges and opportunities encountered during the testing and application of the framework to the case studies, but in a general manner, so no specific to any case of particular, and also more on the context of the implementation on the framework rather than on the assessment per se. So among the challenges and opportunities that we encounter, one important challenge, as I mentioned before, the framework for the first time puts together safety and sustainability dimensions. So one of the challenges is actually to integrate the safety and sustainability dimensions in the assessment, but also the integration of these considerations in early innovation. And in this context as well, the availability of suitable methodologies and tools to predict and generate data in early innovation. Another challenge was the identification and engagement of different stakeholders in the entire life cycle value chain of the chemical material, because this is not a single company effort, and with additional information or challenge on engagement, in particular SMEs. Also linked to this stakeholder engagement, the data availability and how data is shared among the stakeholders in order to be able to fulfill and to perform the SSBD assessment, taking into consideration the entire life cycle of the chemicals and materials. And also linked to this multi-stakeholder engagement need, also the need of creating a common understanding and training in the direction of new SSBD way of thinking, and also developing expertise and skills in this field. With regards to recyclability, recycling is an important part of the safe and sustainable by design framework. And it covers special importance when we are talking about the end of life of products containing chemicals and materials and the need to track them. But being recyclable doesn't necessarily mean being sustainable. And although it's a relevant aspect, is one among many other aspects from which one cannot extrapolate to the whole SSBD performance. Said that, and as it has mentioned, the Safe and Sustainable by Design framework is a framework established for research and innovation activities, and in this context supports and promotes new scientific and technological developments. Therefore, it provides the scientific means to development and move to more recyclable flame retardant materials, and enables the demonstration of their safety and sustainability performance. And I hope that I answer all the questions.
Indeed, yes, sorry, of course. Thank you very much, Iranza. Thank you for your very comprehensive answer and for mentioning, of course, the work that the GRC is doing on this topic, and of course for mentioning the case studies you're working on, the workshops, challenges and opportunities. And I noticed that one of the challenges you have mentioned is creating a common understanding and a multi-stakeholder approach. So that's also one of the purpose of today's event. So to having different stakeholders in the same room and of course online to discuss on this important topic. So thank you very much for your contribution in the discussion. So moving on now to the next speaker. So Chris Slutweg. You're an associate professor of physical organic chemistry at the University of Amsterdam in the Faculty of Science. So we would like to hear more about your work when it comes to your active contribution to critical reviews, shedding light on the environmental behavior and toxicity of specific flame retardants. So your work has highlighted some, among others, some knowledge gaps and underscores the urgency for enhancing analytical methods and broadening monitoring initiatives. So based on what we have heard also today, what key insights and implications have emerged from your critical reviews regarding the presence and potential risk and imperative for continued research and regulatory action on flame retardants?
Thanks a lot, Regine. And it's a real pleasure to be here with all stakeholders involved on this important topic. So some key insights that we gathered from academia. So this is a academic perspective only, and that's why I'm really curious and exciting to share thoughts and discuss everything with you, is that with the advent of the circular economy, the EU Green Deal, the chemical strategy for sustainability, and obviously also safe and sustainable by design, there is much focus on the need for sustainable flame retardants too. And then it's the question how to do this. And when I first heard of the circular economy, I thought, how is this wheel spinning around? And that actually led us to develop the concept of circular chemistry. It's actually the need for circular technologies to enable the development of the circular economy. And currently still depleting resources are converted into products. This also accounts likely for flame retardants. And with the focus on green technologies, there is a need for renewable resources. But actually often those renewable resources are implemented in the linear economy. And so it's really, we need to develop a true circular economy where products become renewable, so that you can actually design products such that they can be recovered and can be recycled, or ideally the recovery and recycling is fully linked to each other. Now, designing products as such is a challenge, but also designing additives like flame retardants brings another challenge, and it's from an academic perspective only a more exciting research topic. So questions that we need to address is a product with added flame retardant suited for recycling? How can this be developed? Do we need to redesign the product and or the flame retardant to make it feasible for recycling? Or if by definition recycling is not feasible, and then perhaps it's better that the flame retardant becomes biodegradable, so that if it leaches into the environment, it causes no harm at all, and then the respective elements of the flame retardant are basically taken up by the biogeochemical cycles. And so this actually links to the persistence versus durability concept that Adrian discussed. Can we design products, including flame retardants, for multiple properties? As a function of the product, function of the flame retardant that is added, and its durability, that will allow recycling. But if that recycling is not feasible because it washes off into the environment, then it's really design the function of a product and the degradability of the materials that may enter the environment. So typically, and the safe and sustainable by design concept, I truly admire, and I like to implement it also from the making molecules and materials perspective. And typically, I mean, this is my view from academia, the environmental sciences that has led to REACH, has led to safe and sustainable by design, is often decoupled from the synthesis, from the making of molecular materials, at least in academia. So we need to bridge those worlds and bring them together. Multidisciplinary, interdisciplinary is needed to develop sustainable flame retardants, or even more sustainable flame retardants. And this is key for the education of upcoming scientists, people who work in industry. So for the safe and sustainable by design framework, I think it's interesting to add the focus on synthesis there too. So how can we design flame retardants using renewable resources, but also ones that are non-toxic to the environment, non-toxic for humans. So I'm actually quite curious to discuss that, how to realize that perspective, and also from an academic viewpoint, where we're trying to develop such a framework that integrates safe and sustainable by design with green and circular technologies.
Thank you very much, Chris. Thank you for your answer, and thank you for bringing the academic side, the academic vision inside today's discussion, for mentioning, of course, the need for more circular economy, and of course, whether it should be recycling or more biodegradability. So thank you very much for touching upon these important topics. So we move now on to the next speaker, who's going to bring more the industrial vision to the discussion, Laurent Tribu, who works at, who's representing here Schneider Electric. So as a representative of a multinational company specializing on digital automation and energy management, how do you envision integrating fire safety consideration, including the use of sustainable flame retardants, which is the topic of today's event, into the development and implementation of digital automation solution for sectors like energy and transportation?
Thank you very much, first of all, to invite me to this discussion. The fire safety, first of all, is at the heart of the E&E product design rules for decades. So it's not a new topic for the manufacturer of E&E product, because we are selling and producing some product like breakers, like arc flash detector, like smoke detector, and all these equipments are ensuring safety of the electrical installation. In addition to this general product, we are also designing some new equipments like temperature sensor or some gas detector, which are included in some cabinets in order to detect and prevent a fire before it starts to ignite. This early detection is definitely at the heart and at the beginning of all our work around fire safety. We spoke about the statistics of home fire, and around 15 to 25% of the fire, depending on the sources, are coming from electrical installation. And in many cases, they are due to an obsolete equipment or to a bad installation. So what we need to reinforce as a basic rules is that the installation should be made by skilled people and maintained regularly. So generally, in the instruction rules of the equipment, it is mentioned that we need to test every month or 3 months the equipment. So it's something which is definitely not performed by the majority of people, but it can help a lot to detect faulty equipment and then to increase and the safety and reduce significantly the risk of fire. And then regarding the conception of our equipment, so they are including flame retardant material, especially for very critical parts which are in direct contact with the live part or also with the electrical arc. Not all the plastic parts in an equipment are including flame retardant. So it's just for the essential use. So it's an important term for everybody, but we will not add flame retardant in a material if it's not definitely needed. For Schneider Electric, just to give you an idea, we have around 50% of our material which are flame retardant. So it's a big part of our material and our consumption. It's mainly polyamide flame retardant or polycarbonate, but also some other engineering plastic. And this material, as mentioned by Adrian, can sustain a very high temperature without ignition. So that's what we want to achieve through this addition of flame retardant, is to avoid the ignition or to avoid the flame spread using some material which do not create some flaming droplets. And as mentioned also by Adrian, we have for the moment, we have two main fire tests, which are glow wire and UL94, which is a flame test with open flame. But we need to consider for very critical buildings, maybe to add some requirement in terms of smoke generation, in terms of smoke toxicity, and it is already the case in railway. In buildings, if it's a really critical one, it can be definitely considered. And regarding the new energy landscape, it's creating new field of research and development for flame retardant material. So we have many new challenges. So first of all, we have an increase of the voltage. In many applications, we start to hear about 800 volts, 1,500 volts, and so we are just at the limit of the medium voltage. And in this case, what can happen is some partial discharge within the material. So it means internal burning of the insulating material. So it's something which is creating some needs for new material, new developments. And we need to take care that the new material which will cover this risk will be used for this electrical vehicle, for example. Another challenge is the replacement of alternative current by direct current for some installation or for the complete distribution. For example, in China, they are considering the possibility to go for DC current also for the main electrical distribution. And in this case, what we have to think about is that due to this DC current, we can have some migration of substances within the material under the permanent electrical field. And that can create some new risk of tracking in surface if these particles which are migrating are conductive. We heard a lot in the news about the flashover or blast of battery pack, and that's some new challenges we are discovering with the electrical vehicle. And you notice that many companies, many supplier of material created a very innovative plastic material which can sustain more than 1000 degrees C before ignition or collapsing. And finally, the overheating is also critical because when you are charging a vehicle, you are using a lot of power for a very long period. And then you need to really take care about the selection of your conductors in order to avoid the overheating and then the burning and fire. And on top of all these requirements, which are electrical performance, mechanical performance, we need to design products within Schneider for a very long lifetime. So 20, 30, 40 years, even more for nuclear power plant. We are speaking about 60 years before dismantling the nuclear power plant. And then what we need to confirm with the supplier of flame retardant and supplier of material is what is the aging of the fire performance of this material after such a long time. Can we have a decrease of the performance? Is it stable? So all these topics will need to be addressed soon to ensure a safety by design product. In parallel to all these challenges, we have also a new one, which is the end of life of the product. So we used to consider just a single use, and then the material went to a landfill or incineration. Incineration for flame retardant material is just crazy, but landfill is not better. Sorry. So in this case, what we have to think about and to work with supplier is a good recycle process, and this recycle process needs to is in competition with the substance regulation, which is emerging also or growing within Europe, but also outside of Europe, with the progressive banning of hazardous substances. So if we want somewhere to increase the recycling rate and all the legacy products are including some hazardous substances, we see that there is no possibility then to recycle this product. So we need to find some new routes for recycling, which can be chemical recycling, to remove the legacy hazardous substances from the material and generate new material, which can be, once again, flame retardant with the best-in-class flame retardant. And how to select this best-in-class flame retardant? For the moment, unfortunately, we have very few positive lists of good flame retardant available. So within Schneider, we decided to follow one specific company who is doing this assessment of the toxicity of substances, which is called Green Screen. But we would be more in favor of maybe an official methodology approved by Europe for the assessment of toxicity of chemical substances that we can follow. Just to give you some positive message, there are more and more new startups and new companies which are proposing what they call really sustainable flame retardant, which can be polymeric flame retardant and not just inorganic flame retardant. And in this case, it can give some new possibility in the future to have a safe and sustainable product. Thank you.
Thank you very much, Laurent. Thank you for presenting, as I mentioned before, the industrial vision into the discussion, and also for mentioning how a concrete example of application of fire retardants at the Schneider Electric. And I particularly appreciated some suggestions that you brought forward, specifically when it comes to, of course, having a clear timeline of the use of flame retardants and what happens when we arrive to the end of life of the product. So thank you for bringing those aspects forward. Before moving on to the next speaker, who's Christophe, who's joining us online, I would like just to remind the audience who's connected online. We have actually 60 people who are connected online, which I think it's a great number. But just we're reaching very soon the Q&A session. So if you have some questions that you would like to ask to the speakers, please make sure to insert them already in the chat box so that I have a tiny bit of time to also structure the Q&A session. Coming back to the panel discussion and addressing a question now to Christophe Biscoupe, who's the chair of the European Fire Safety Alliance. So how do you propose addressing the emerging fire safety challenges associated with Europe energy transition, considering the increasing use of organic material and sustainable flame retardants? And together with many other organizations working on improving fire safety in Europe, the European Fire Safety Alliance is calling for an EU to develop a fire strategy, fire safety strategy. So can you please explain to us how do you see the role of the EU in this regard?
So thank you very much, Regine, for invitation and for this question. Good afternoon, everybody. So as always, my approach will be marked by my experience from Fire Brigade, where I was serving for 30 years. So we need to remember that fire safety is a very complex challenge itself, and ongoing energy transition made this challenge even bigger. Because of the energy transition, our surrounding is changing and getting more and more complex. And of course, on one hand, these changes are, I would say, crucial for achieving higher energy performance and sustainability. But on the other, they result in higher fire hazard and less predictable fire environment. For example, to improve energy performance of existing buildings, they need to be renovated. And we need to be aware that there is a real risk that energy renovated building might become more dangerous for people than before renovation, what undermines the whole sense of this activity, of course. In 2020, the main fire safety challenges and problems in the EU were defined by fire safety professionals in the European Fire Safety Action Plan. And 1 out of 6 fire safety challenges considers purely the energy transition, and it says the fire safety must be an inseparable part of the energy transition. Why? Because there is insufficient awareness, knowledge, and competency regarding the new fire hazards associated with the energy transition. And to improve the situation, it was proposed to develop knowledge and competency to ensure fire safety adequately accompanies the energy transition and address the fire risks associated with the new forms of energy, and of course, ensure regular inspections of installations and appliances in buildings. As for sustainable flame retardants, they also play a relevant role, offering numerous benefits for fire safety, which were very well explained by Adrian in his keynote presentation. But at this point, I need to underline that to be properly addressed, fire safety requires a holistic approach, covering all aspects of fire safety, including prevention, detection, early suppression, evacuation, compartmentation, structural safety, and finally, of course, firefighting. And only such comprehensive approach can guarantee that people in energy efficient building will be fire safe. So, and now let me say a few words about the fire safety strategy we are calling on the EU to develop, and which was very well introduced by our host MEP, Mr. Adam Jarubas. Thanks you again for hosting today's meeting and also the meeting last November. So as we know, fire safety is primarily addressed by building codes that are a national competence. And of course, I have no doubt it should remain like this. Member states should feel free to shape their own fire safety regulations. But action on fire safety, especially fire safety in buildings, goes beyond building codes. Because building codes doesn't cover many important fire safety aspects. Let me provide you a few examples. For example, fire awareness, some elements of prevention, fire statistics, research, market surveillance, or even information exchange. In our activities on fire safety, we have quickly noticed that European Union institutions have high potential and also great interest to coordinate actions and support member states because fire safety impacts and is impacted by several of the EU core objectives, mainly objectives concerning energy transition, but also tourism, environment, human health, or consumer protection. So through the harmonization of fire statistics, which is collected by member states, by shared fire safety research and exchange of experience, the European Union offers a quite unique perspective that will enrich and strengthen the development of knowledge in the field of fire safety and help to address common challenges across the member states. Even now, fire safety of buildings is addressed by the EU in several regulations and initiatives. For example, in the Energy Performance of Building Directive, the Construction Products Regulation, in some EU co-founded programs like Erasmus+, like Horizon Europe, or the projects aimed at harmonization of fire statistics, which are funded by the European Parliament. Another very important initiative is the Fire Information Exchange Platform, which is run by the European Commission. By the way, yesterday we had a very good FIEP webinar on fire prevention and intervention. And of course, during the discussion, especially during the final discussion, a participant underlined that fire safety challenges are common for all member states. And at the end, there was somebody raised a very good question, which is very important, especially from the perspective of firefighters. How to shorten a time between placing the product into the market and knowing how to react in case of fire. Because at the moment, there are many, let's say, appliances, installations where firefighters really face a very big problem and put their life into risk because we don't know how to, let's say, cope with these challenges. So that's why we believe that the European Union must play an important coordinating role on fire safety. And on this, together with several stakeholders, and we were also supported by some members of the European Parliament, we have launched the joint Keep EU Fire Safe campaign. In this campaign, we are calling on the European Union to develop a fire safety strategy in coordination with member states. So if you want to learn more and if you want to support the campaign, please visit dedicated website keepeufiresafe.org. And as I know, two of my colleagues, Eugenio and Olivier, are in the meeting room in Brussels, and they can also provide you with more information about the campaign, and hopefully they have some hard copies of the Fire Safety Manifesto, where we proposed 10 aims for the EU fire safety strategy. So thank you very much.
Thank you very much, Christoph. Thank you for mentioning the work of the European Fire Safety Alliance, of course, from providing more information when it comes to your call for a EU fire safety strategy in the EU. So we've reached now the Q&A session of the event. Of course, I would like to thank all the panelists of today's event for your insights in the discussion. And I would like now to provide the floor to attendees in the room. If there is anyone who would like to address a question to the speaker, I see one hand raised. If you can present yourself.
Yes, hello, I am Ioana Bere from the NGO ChemTrust. I have heard several times from several speakers saying that the energy transition will lead to more fire cases. And I was wondering, are there any official statistics on this from Eurostat, from member states, or are these just forecasts that stakeholders put together? Thank you.
So I think that it will be a question addressed to me.
Please go ahead, Christoph.
At the moment, of course, locally we observe the rise or the increase the number of fires related to appliances or installations assisting the energy transition. But at the moment, we haven't such, let's say, big data on the issue. And that's why we are very happy that the European Parliament adopted a project within the so-called preparatory action. This project is aimed at developing the harmonized EU fire statistics, what means that we can easily compare the data from one to the other member state of the EU.
Yes, maybe also a quick comment on that topic. I'm also not aware of any comprehensive statistics yet. I think that they will probably come as we keep using these technologies. But we all have seen cases of, for instance, photovoltaic installations that caught fire, whereas before they weren't there. Yeah? And also electric vehicles or battery storages in homes for photovoltaic energy. Those cases are new, but in parallel, also industry is working on addressing those risks, developing new standards. So it's not the case that we can observe, oh, we just let it go and then see how many fires we have, and then we start developing new standards or regulations. It goes hand in hand. So it's difficult to judge by the number of cases how big the problem was, because it's being tackled as we go along, right? So, yeah.
Yeah, I think I addressed some challenges regarding the potential risk which are emerging from this new technology, especially the increase of the voltage and the use of DC current. Definitely, if the installation is well done by skilled people, and if we are tackling this the issue by design in the early phase of the product design, there is no reason to have a real increase of the fire and the fire number and fire statistics. But we are really working right now on this topic. And for example, the electrical vehicles, we had some discussion with automotive manufacturer because they were not used to make some design of electrical component. And they were wondering why we were using glow wire testing, if it's good enough for their own fire risk. And that's such topics where we have a few background, a few information, and we need to really take care to cover all the aspect of this new equipment, let's say. For the breaker, for all our E&E equipments, we have more than 20, 30, 40 years of experience. So we know how to ensure the safety of this product. But for an electrical vehicle, they started quite not a long time ago.
Any other question from the room? Yes.
Hi, I'm Marianne Rosborg from the construction company Rockwool. I hear both from the producers and the users that there's a huge challenge with materials. And I see Laurent is nodding. Laurent, you specifically mentioned that you've seen in the media some attention to some polymer-based materials that can withstand temperatures, what was it, 1,000 degrees. And all I can say that the lesson I would definitely take out from today, that is materials matter. And what we see also with a lot of polymer-based materials is that they actually have a challenge at end of life. For example, pulling out the flame retardants. So how are you tackling this material choice, this challenge? And because, for example, I know now that some insurance companies, they're saying for my sector, for construction, that if you put a PV panel on your roof, then you have to put something underneath that won't burn. So you're seeing this sort of more holistic approach to fire safety, but how do you address it also with the materials that are available on the market today?
So the material have been assessed for certain fire performance. So the main fire test we are performing is the ignition temperature. So we are checking what is the maximum temperature which can be sustained by the material before igniting. And generally, the temperature we are speaking about is around 750 degrees C or higher. So we already have some, we are not speaking about 100 degrees C or more. We are really thinking about a start of or arcing condition or close to arcing condition with or flame condition. And in this case, we already have some material available which can sustain this fire performance. But in addition, just to the delay of the ignition, we need to consider all the other properties. So the mechanical performance, so the electrical performance of the material, and it's reducing definitely the choice of flame retardant we can include in different plastics. So not all flame retardant can be used in all plastics. It would be too much simple. Because we also need to consider the compounding phase of the material. If the thermal stability of the flame retardant we want to include in the plastic is not good enough, it will decompose during the mixing of the component, and at the end we will have a reduction of the flame retardant content in the material and not a good product. So it's always a compromise between the fire performance, mechanical performance, electrical tracking, and all the rest. And it is basically my job, because I'm plastic expert for Schneider Electric, my job to first to test it at room temperature, but also to test it after aging. And that's one topic I addressed in my presentation, is that we need to consider what is the performance of the material when we buy it first. But after 40 years, we need also to ensure that the performance will be the same. And how we are trying to accelerate the aging is through accelerated aging in oven at elevated temperature or in humidity or specific moisture condition. And we check if we have some release of the flame retardant, the migration in surface, and such material with not so stable flame retardant, we try to avoid it, or we discuss with our own supplier to understand why it is not stable enough, how we can improve it. And we have to say that the problem of persistency compared to durability is definitely a big question for us. Shall we continue to use very durable material, or shall we ensure that it will be possible to degrade these substances in the environment easily at the end of life? Or something in between is the recovery of the flame retardant through a recycling process, and chemical recycling, as I said, for the legacy product, but also for non-legacy product can be a solution, because we will be able to extract some substances and to give a new life and a new initial performance to the material by reformulating the product after the first life. I don't know if I answered your question. Okay. Thank you.
It works? Yes. Okay. Jakub Stefaniak from Association of Expanded Polystyrene, UMEPS. Firstly, I would like to thank to MEP Jarubas for supporting the Fire Safety Manifesto. And I have a question to our speaker from JRC, from, I hope I pronounce it correctly, Irancu Garmendia. If you could sum up when we can call a flame retardant sustainable. And I have a second question to the Professor Slodvech about this biodegradable flame retardant. Because you mentioned that it would be important that such flame retardant biodegrades when it leaches to environment. But then my question would be, for what type of product can we use such flame retardants? Because if there is a risk of leaching to the environment, my understanding is that this flame retardant can biodegrade during its shelf life. So for what type of product can we use it? Thank you.
Shall we maybe start with Irancu with the first question?
Yes, thank you very much. And yeah, very correctly pronunciated my name and surname. So as I mentioned before, currently with regards to the safe and sustainable by design framework, we currently in the JRC are basing our efforts in testing the framework and its implementation. The question with regards to the outcome of the assessment on whether a flame retardant in this case or a chemical or material is rather safe or sustainable. In the case of the SSBD, it should be both safe and sustainable by design, considering the entire life cycle. It's a question that needs to be answered when the assessment has been performed by the corresponding experts in the fields.
Yeah, thanks a lot for your question. From a conceptual view, I think it's very interesting to design per application of flame retardant the right product flame retardant combination. And so, as also Adrian mentioned, if the flame retardant is durable, this would allow recycling, typically chemically recycling. But if that's not possible, if you think of flame retardants added to clothing and open washing of the clothes, some small amounts of flame retardants could wash it off. If they enter the environment in that manner, then you would prefer them not to be persistent, hampering, the purification of drinking water. And in that case, I mean, it would be ideal if the flame retardant, after its use in the environment, can degrade into the corresponding elements of the flame retardant, and like I said, being not persistent. But I think it requires a case-by-case investigation, which application, which product class, and which ideal loop can we design and close.
Any other question from the room? Please.
Yeah, thanks for this informative discussion. So I'm representing Huber Advanced Materials as a flame retardant producer, and we're welcoming, say, increasing standards which, spark innovation, which also require investment to also bring our industry forward, right? At the same time, we also see that products or parts of products are simply produced somewhere else. If you look at a cable, for example, rather than making it in Europe, is simply made in a different region, or you look at a car, which is simply made somewhere else. How do we make sure that the standards which promote innovation, which also promote investments, help the industry, but also help the industry to survive as long as it's there?
Yes, I think it's a very good question, and I was looking at Mr. Jarubas because I think it's really a political question, not so much to us as the chemical industry. I think that's one of the big challenges of setting very high standards here in Europe, and REACH was the beginning of this. And luckily, REACH did have some regions that follow and copied it, and are slowly also developing in that direction, but it took a very long time. And with this new chemical strategy for sustainability, the question is, will also other regions follow? Otherwise, if we are the only region that has these high standards, as you say, imported products is also, even under REACH, a huge topic. Yeah? What about the chemicals in imported products?
Maybe if I can add a comment. At Schneider, for example, we are applying the same rules worldwide. So we are considering that the life of people has the same price everywhere in the world. So meaning if we identified substances which can be hazardous for our customer, we are doing all our best to remove it from our product, whatever the regulation, if it's coming from REACH, if it's coming from China, from North America. And that's where also it's so important to have a way to assess the toxicity of substances, which is agreed and accepted worldwide. If we succeed to push our own, it would be perfect. But if you can agree also with other geographies on how to make the assessment of toxicity for health and environment of different substances, including the flame retardant, it would be, for me, the best.
Any additional question from the room? Otherwise, I see there are some online. Okay, so I will read out one of the questions that we have received online. So it's a question coming from Simon Levitt, asking, I think it's a question open to all the speakers. So do the speakers think that we're finding a solution which will meet the needs of fire safety and sustainability together, or we will need to agree on compromises and maybe trade-offs?
Yes, absolutely. I think we will need to make compromises even if we start designing products with having recycling in mind, having sustainability in mind, there will be trade-offs. You can optimize a product for recycling, but then you lose on properties like maybe energy consumption during the lifetime. Yeah? Those things. So there will be compromises to be made. And what I think is also important, coming back to this question, what is a sustainable flame retardant? The answer is not black or white. There will be various shades of gray, more and less sustainable products. And what we see so far from the chemical strategy for sustainability and their legal initiatives, it was more about looking into regulating more the assessment of chemicals. Also, SSBD is assessing the chemicals. But what has been really a huge problem is market acceptance of better alternatives. Yeah? And I see little, and that directly to the, say, political world. In regulation, there is a lot about regulating hazardous chemicals, making REACH stronger, expanding its scope, whatever. But to really promote alternatives that are better, I've seen little so far. And that even before SSBD, there are cases also in the flame retardant world where there are clearly better alternatives around, which have not been taken up or simply because the existing solution is widely accepted, is cost efficient, and therefore no one switches. Yeah? And I think that's a topic that is, say, overlooked often when we speak about this whole regulatory aspects.
Thank you, Adrian. There is another question that I think it's maybe open to everyone as well. So how can producers of flame retardant materials ensure the long-term availability of flame retardant substances in the European market?
Again, I think only if we can stay competitive will we be able to produce and offer flame retardants here in Europe? Because we have rather open global markets. Flame retardants are generally traded globally. Also currently a lot of flame retardants are coming into Europe from outside. The larger part, I think, even in products, in finished products, but also the flame retardant as a chemical, they are coming into Europe. But I think it's key that the European flame retardant industry stays competitive. And that means, yes, as also Christian mentioned, we're open to new challenges or tackling concerns that are out there and improving our products. But at the same time, if there's not a level playing field with imported products, that makes it really difficult and tough. And that's, I think, in general, is a big topic for the chemical industry in Europe. Yeah, be staying competitive, which means that we need to balance these different factors properly.
And I think there is an additional topics related to this question is the resilience. And the possibility also to produce our flame retardant from European precursor of this flame retardant, which is also a very important topic. We are also considering as a global company who is using, as I said, more than 50% of flame retardant material. We need to ensure that if there is a crisis for the precursor of this flame retardant, it will not impact all our product portfolio. And there are some activity in this field in R&D, starting sometimes from residue of combustion of other substances. And I think it's really promising also to consider this waste, potential waste, as a source for development of new material. I'm thinking about, for example, of fly ash, for example, which can have an activity in flame retardancy and is currently not considered really is considered as a waste of a pyrolysis process more than a source.
Yes, perhaps you want to, Chris, you want to comment on phosphorus and recycling, urban mining. I think that all comes into play, and you were alluding to critical raw materials. Yeah, we didn't mention the term, but critical raw materials is also relevant for flame retardants. One key example is phosphorus. Phosphorus flame retardants. The company I work for, Clarent, we produce phosphorus-based flame retardants. So currently, the phosphorus we consume here in Europe is coming from very few regions. The yellow or white phosphorus that comes into Europe mainly from Kazakhstan, but other phosphorus products mainly from China. So that again, there's an important aspect.
Yeah, that's a good point. I mean, for the energy transition or the development of a circular economy in general, we rely on elements that we now call critical raw materials. When we succeed in developing the circular economy, those should be named circular raw materials. So it only is critical because we are dependent on them and we use them in a linear fashion. So it's really the objective is to try to close all loops. And this is important for any element, but phosphorus indeed is a key biogenic element needed for life, sustaining life, but also a key one for making sustainable flame retardants. It's also there to develop new processes that convert energy efficient, resource efficient to make the sustainable flame retardants, and also allowing the recycling of them indeed is crucial. So it needs new R&D methods, but also the adoption of new flame retardants in the industry and society.
Thank you. I would like maybe to address the last question received online to Laurent. So it's linked to your intervention. So you mentioned that you would like a list of suitable and sustainable flame retardants. But on the other hand, the REACH is regulating what chemicals go into the value chain in Europe. So a new listing, wouldn't it be a conflict with REACH?
Not at all. I think it's what I'm speaking about a positive list is a list of substances with the lower risk to be regulated by REACH. So meaning having been assessed in terms of toxicity in the good manner, but also to have demonstrated a low impact in terms of CO2 generation during the production. So it can be another aspect of this positive list, which can be considered. And we can imagine to have a scoring of the best in class substances, which is already existing, as I mentioned, but it can be challenged because it's not, it cannot be seen as an official methodology for the assessment. So it's better to be accepted and let's say validated by ECHA, for example. And if we have this positive list, it will help us a lot to make the right choice. And currently, because we did not find this positive list so easily on the market, we went through, as I said, green screen scoring. And when you look the best-in-class flame retardant, you just have 2 or 3 substances which are with higher performance in terms of sustainability and the lower risk for safe health and environment. The magnesium dihydroxide, which is metal hydroxide, which is releasing basically water when it burns. So it's for sure one very good candidate, but unfortunately we cannot use it in all the plastics because we need to put more than 50% of this material, of this flame retardant in a polymer matrix to get a good fire retardancy. So it can be used in synergy with others, but alone it's quite difficult to use it for all the polymer matrix. Another one is ammonium polyphosphate. It works for some plastics, but not for the others. So we need positive lists with multiple substances which can be used in multiple polymer matrix and provide this information largely to the end users.
Please, Adrian.
Maybe just to add to that, this green screen assessment that you mentioned does not just have 2 categories, yes or no, black or white. It has red, orange, yellow, green, and I think that's also a model perhaps to be considered in Europe, because REACH says this is okay to use, this is not okay to use. So SGSC or the like, or other chemicals that are okay to use. But to differentiate between those okay to use in Europe, between more preferred, less preferred, I think that's what you're asking for, right? Okay.
Thank you very much for answering this last question, because as of now we are moving towards the end of the event. So, one additional question. Okay. Okay. Yeah. Well, we need to finish in 2 minutes, so very short.
Sorry. With the ECHA work that is ongoing now, that is derived from the strategy that was published last year on flame retardants. There will be proposals coming for several groups that will be possibly restricted under REACH. Could that not end with the positive list that you're looking for?
I'm crossing fingers to have these positive lists. And also regarding grouping, it's definitely a big issue for us. Because as I mentioned, we have not so many flame retardants available on the market actually. So if we restrict really by group the flame retardant, at the end we will have basically no option available on the market. And also what is important is when ECHA is putting a new substance under regulation, we need to take care that it's possible to make the assessment of the presence of this substance in the material. And all the methodology to make the quantification of the flame retardant or the other substances is not always provided by ECHA. And then we can have some people from other geography which are proposing some material which are not complying with the regulation, but nobody can make the assessment. And that's one key topic also is when we put regulation on substances, we need to take care how we can make the verification of the compliance.
Thank you. So I would say that based on the level of engagement and the questions that we received both online and in person during today's event, the topic of safe, sustainable flame retardants and European fire safety and the transition towards a green future is getting a lot of tractions in the EU. So I would like to thank our excellent set of speakers for the active engagement in the discussion, and of course, to all the attendees connected online and in person for staying with us towards the end of the event. I don't want to take additional time. I have some closing remarks, but I would just leave the floor to Mr. Jarubas for his closing remarks.
Thank you. Yeah. Both. Thank you very much for an interesting discussion. Many arguments and information was presented, raised today. Thank you for creating an opportunity to get to know what flame retardants are. How does it work? And I think we all agree that there is no safe Green Deal without preparing adequate solution and measures in the area of fire safety. Many issues can be addressed already at the design stage and at the material used. I hope that the new Commission and the Parliament will listen to the calls raised in this meeting today and others, like our meeting in November, the call of the Fire Safety Manifesto 24-29, and I hope that the coming term will be the term of, among others, the European fire safety strategy. I thank you all for today's meeting. Have a good afternoon.
Thank you.
Thank you very much.